I am Chad Phillips, CTO of Apartment Lines, and I'm here today to talk to you about using XML templates to get data out of LLMs reliably. And before I get into the slide presentation, I just want to take a second to set some context. In my opinion, across the AI landscape, a lot of attention is paid to what I would call frontier AI. So the latest and greatest models, the promise of general intelligence, artificial superintelligence. And along with that, there's this kind of concurrent dream that there will someday be intelligence too cheap to meter. What I would like to contest is that there's a less hyped kind of intelligence that I would say is here today. I would call it intelligence almost too cheap to meter. I heard it alluded to a few times in some of the earlier presentations, which was very pleasing to me. And what I'm going to show you today is an example of that intelligence almost too cheap to meter. So how many of you can relate to the prompts in that slide? I know I can. That's bribing your LLM. It's coercing it to try to get structured data out. And it illustrates a particular challenge when you're trying to extract value from a language model, especially in data pipelines, which is how do you reliably get structured data out of a non-deterministic resource. And my premise today is very simple. It's that using XML templates in your prompts is an easy way to get highly reliable, low-cost data extraction. And it's a method that works with just about any language model that you can find. This is the basic pattern. It is XML, no surprise. But to review briefly, it's got a root tag. In my case, I'm using an analysis tag as my root tag. Inside it, there's an optional reasoning tag. You can use this if you want to allow the model a space to explain why it's making the choices it is. Following that will be one tag for each piece of data that you want to extract. And then in the rest of the prompt, you would instruct the model to replace those instructions that you see inside curly brackets with the actual data value. So why XML templates? Like, what are the reasons that this is such a great pattern? Well, first of all, the tags act as like guardrails. They force the model into a more deliberate pattern matching process, and that improves your reliability and your accuracy. LLMs are native speakers of XML. They've seen massive amounts of it in their training data, and they are really good at writing it reliably. A lot of times, when you ask a model to output any kind of structured data, it has this sort of habit of outputting conversational filler around the structured data. And XML is quite easy to parse, which means you can take your full response and get the structured data out of it with a simple regular expression. And then finally, using XSD schemas, which are widely supported in probably just basically every programming language, you can get your entire data structure that you pull out and any potential allowed values fully validated. And as I said, that's going to be across all kinds of programming languages. So this is definitely not a talk on prompt engineering. There's lots of resources you can look up if you want to get better prompt engineering. But I do want to at least provide kind of an overview of the components of the prompt I use along with the template to kind of really make it work. So I'm hoping that this is big enough everybody can read it. It looks OK. To orient to what you're looking at here, this is a Python Jinja template with some YAML front matter at the top between these kind of straight lines. In the top section is a system message, and there I give the model a role. It's a metadata analyst, and then a series of rules. And the rules are really just meant to take this general ability model and focus it on the specific task that I'm going to give it. Then here I provide it the task, along with where that article text variable is. That's going to be the data that's going to analyze. In this case, the data is a full Wikipedia article. Following that are a bunch of field definitions. These are basically, I'm describing how the tags and allowed values are going to work. So I've got a very clear description of the XML tag that's going to be used. I've got a list of allowed values that can go inside that tag. I've got kind of a hint that sort of guides the model about how it might look at the data and get the valid metadata value out of it. And then finally, in each section, I've got this list of example output formats. And it is an exhaustive list. It's a full example tag with the allowed value for all of the allowed values, which might seem like overkill, but it's a minimal amount of additional context, and I find it really helps to guide the model to stick to just those values. At the bottom of my prompt, I've got the template itself. You can see that here. There's the reasoning tag plus 7 different types of metadata that I'm going to be taking out of the Wikipedia page. And above it are just some simple instructions to guide the model about how to complete the template. So that prompt, in order to work in a data pipeline, needs to be in some kind of workflow. And I chose Python to implement that workflow. I'm not going to get into the code. It's actually not super interesting. It's super useful, though. So I did make it available on GitHub. You can see the location at the bottom of the slide there. It'd probably do 80% of the work for you if you wanted to do something similar to what I'm going to show you. But broadly speaking, I'm loading the data, which in this case are full Wikipedia pages. I'm going to take that data and combine it with the template I showed you to generate the full prompt. Then I'm going to call the language model and let it run inference. When I get the full result back, I'm going to use the regular expression to extract the XML from it, and I'm going to run that through a parser to get it and get the XML into a Python data object. Then I'll use XSD to validate that, make sure that's a valid data structure, and finally I can optionally store that. So how well does it work? I'm hoping this table will pretty clearly illustrate that. So a couple of things to note here. This experiment I ran 60,000 Wikipedia pages. I ran it across 6 different language models. I loosely organized them from the models with the most parameters at the top and smaller ones at the bottom. Those are, by the way, off-the-shelf models. I didn't do any fine-tuning. The only instructions it got was the prompt. Each model did 10,000 pages, and each model was fed the exact same prompt that I just showed you with, of course, the data of that particular wiki page injected. So if you look at the success column, and in particular the success percentage column, you can see it's very reliable, averaging over 99.5%. Only Minstrel, the 5th one down, I think, performed a little bit under that, but they all performed quite well. If you notice that retry column, I do have a retry mechanism, which I will talk about just a little bit later. But I can tell you that the retry mechanism helped to pump up the success rate. And finally, and I think most importantly, look at that cost column. I mean, with the exception of Gemini 2.5 Flash, which is more expensive but hardly expensive, you can process 10,000 Wikipedia pages, pulling out 7 pieces of metadata for a couple of dollars. That's fractions of a cent per page to get that information. So think about any large amount of data you have in your own business where you might want to get metadata out of it. You can do it super cheap. And that's what I think of as intelligence too cheap to meter. Or, well, almost too cheap to meter. So there are valid reasons why you might not want to take this approach. I thought I'd try to cover a couple of common ones. The first one is XML is very wordy. It's verbose. And because it's verbose, it takes up more tokens, and more tokens means more cost. And that is definitely true. What I can tell you is that from my experience using this pattern, while I am putting in more input tokens, I'm also able to use smaller, cheaper, faster models to get the data out, which pretty much offsets the argument for having more input tokens, in addition to the fact that, I think as we've all seen, over time, the context windows of the models grow, and the inference costs shrink. And so just time passing kind of makes this objection less and less relevant. How about using the native tools that are available, like OpenAI's structured data mode or JSON mode? Why wouldn't you just use that? That's probably plenty reliable, and I'm sure it is. The big problem there, of course, is that you might have to deal with vendor lock-in. Whereas if you use XML templates, let me just go back to give you guys a real look at that. That is 6 different models from 6 different providers using the exact same prompt. And that's the reliability I get. So it is super portable. So yes, you can use something that's proprietary, but you probably don't need to if you use this. And you can switch models and providers as you like to be able to do what you want with it. So another one is, well, why use XML? I don't want to add more complication to my pipeline. It's already all JSON, et cetera. And I think the thing to focus on here is that the XML is transient. It is a mechanism. It's the best available mechanism I've found to communicate between the application code and the language model to get what you want out of the language model. As soon as you have it out and you've parsed it, then it's going to be in a native object in your programming language, and you can continue it on down your data pipeline, whatever storage mechanism that you want. So the XML is transient. And finally, well, this is not an XML feature. This is just good prompting. Yes, that's correct. I agree. And what I would to add to that is that it's good prompting because XML is a superior format for this kind of data extraction. The nature of the language means it's really easy for the model to understand and comply with, and it's also extremely easy for us to parse. OK, so that's the basic idea. With that alone and the code that I published on GitHub, you could get things going pretty reliably. But I have learned some other things. I've implemented this pattern over several large projects, and so I thought I'd share some additional tips and tricks. I alluded to the retry mechanism earlier. I call them UUID retries, which I'm not sure if that's exactly the right name, but I'll explain why I call it that. So if you look here at the task section, this article text variable, that's a Jinja variable, is where the Wikipedia article goes. It's surrounded by XML tags, so just to kind of let the model know where the article begins and ends. And the Wikipedia tag has an ID attribute. That attribute is substituted dynamically with an 8-digit, I believe, random identifier for each individual inference run. And so if a model fails, and when I say fail, I mean it produces invalid XML, or it skips a piece of metadata that I asked it to extract, or it outputs valid XML with valid metadata types, but it screws up one of the values. Any of those things would result in a failure. Then I will resubmit the exact same prompt, with the only difference being this small identifier. And I don't have hard data for this, but what I'll tell you is it works. If I go back here again and you just look at the amount of retries, like look at Quen, it had over 1,000 retries and only 47 failures. That means that on the second or third try, because I give it 3 tries, it will figure it out. It'll get it. And that is entirely a function of the slight input variation from this identifier and just the non-deterministic nature of the models. If that's not enough to get your reliability higher, or you're not getting enough, I mean, that was 99.5%, but I want more. So another option would be to extend the workflow and fall back to a smarter model. The models that I used in this toy example were, some of them were bigger, but a lot of them were in the 7 and 8 billion parameter range. So maybe you would give it 2 or 3 tries with that retry mechanism I showed. And if it still failed, now you've got a case that's a little more complicated. That model can't handle it. You might fall back to something like a 70 billion parameter model. It's smarter and probably would be able to handle that. The advantage there is that you get to push your success rate even higher. And since you're using it so rarely, you're not going to push your cost up very much at all. CData, in case I had to learn this along the way, so in case anybody else doesn't know, that CData tag, where the arrow is or whatever, that marker, you would put data inside that tag. And that is a special XML tag that instructs a XML parser. Don't treat anything inside that as XML. And this is super handy because where you're outputting values, like take, for example, the reasoning tag I showed you, the XML, or the LM can get pretty wordy in that reasoning tag. It might output something that breaks the parser, like a special character or something. So by wrapping something in CData, that value inside of a CData, the parser will ignore those special characters, and it'll parse everything successfully. You can put those CData tags directly in the template that I showed you, like inside your XML template itself in the prompt. It works. I've done it before. I personally prefer to inject it programmatically. It's, again, a great illustration of why XML is so awesome is because I can parse, when I get an XML string back, I can parse it into multiple segments and inject those CData tags for each additional tag. I can wrap it in CData and then feed that string to the parser and get even more reliability out of it. This kind of relates to tip number 2. If we look again at the data structure, it's flat. It's only 7 pieces of metadata. The smaller models do a really good job of handling this with a really high success rate. But maybe what you want to get out of your data is something more complex, a lot more pieces of metadata, or your data structure is hierarchical. And at a certain point, these smaller models will just not be able to keep up, and they'll start failing a lot. In that case, you would want to use a smarter model. I've done some fairly complex data structures using smarter models, and I can tell you that it does work. So my recommendation here is start with the data model. Design the data model however you need it, and then just start with the smallest model you can think it'll tolerate, and then look at your success rates and keep gradually increasing the intelligence of the model until you get to a place of cost and reliability that works for you. And finally, I did mention the XSD schema stuff before, but I should further mention that AI, since AI is really good at writing XML, it is also excellent at writing XSD schemas. And so here is the XSD schema for the toy example I just showed you, right? So this XML validates against this whole giant schema here. And I did not write this schema. I just fed this prompt, the whole prompt, into Claude or whatever it was, I don't remember, and said, hey, can you please generate XML for me, an XSD schema for me? And it spit this out. I made no adjustments to it. Works perfectly. And once you got this schema, any language will have an XSD schema validator, I would imagine. So it's portable. It's also makes it quite easy to extend your data structure. So, say here, I wanted to add a new piece of metadata I'm extracting from my Wikipedia page. I would just add a new tag here with some additional instructions. I'll come over here to my XSD. I would pop in a new element below this one. If I want to include any required values, I would do that. And then I'm ready to go again with a brand new structure. So it makes it super easy and portable for data validation. That's it. That's the whole thing. What I would say in summary is you do not have to bribe your LLM if you give it a clear blueprint to get structured data out of it. And I believe XML temp, well, they're the best thing I've found to do it. They are model agnostic. They work really well with smaller, cheaper LLMs, and they give you near 100% success rate when you're trying to extract data.
Woohoo! Big round of applause for that man before the questions. And we do have time for one or two questions if there are any.
Super efficient, right? I'm a fast talker, yeah.
Chad, I'll look out from the same vantage point of view.
I mean, I don't expect any questions. XML's boring. And this is pretty obvious.
Everybody loves a bit of something with ML at the end. Do you remember voice ML, voice XML? Yes, there's a question. Nick is coming to you, and then we'll go to you afterwards, Jack, and that'll have to be it for the questions. You might need to press the button on it, sir.
Is that better?
That's
there you
better.
Go. Can hear you.
How about now?
Yes.
There you go.
Do you happen to have the same table of your XML encoding for JSON that showed the additional failures above XML?
I don't. I mean, what I can tell you about JSON is I did read a study. Let me see if I can pull up in my memory this study. There was a study done that said if you don't know your data structure, I'm being a little hand-wavy here, but it was essentially like if you don't know your data structure ahead of time, JSON is actually superior to XML. For extraction, meaning like it will output valid JSON more often. But when you get to the point where you know your data structure, XML is basically on par. And of course, with these XML templates, you get the additional parsing ease and stuff. And I would add that I really do think that the way I don't know, again, but the way I designed it with the curly braces, because I did a lot of iterations to get what I just showed you guys today, right? It was many hours of work. And the substitution of values with the instructions seems to be quite reliable. Like the model, it's like it focuses the model like this is a pattern, match it in the way that I'm telling you, and it makes it really reliable.
Great, thank you, Chad. We got one just there, Nick. Young Jack. I know it's slightly longer for you to walk, but I thought... Here we go, Jack's question.
Nice, always so nice to bring me the microphone. Okay, so did you see the Claude Code stuff yesterday?
I did not, no.
Okay, so who was it? Who opened up Claude Code? Was it Brian West? Brian, he opened up Claude Code, and he said, for the SignalWire AI agent, and I opened up Claude Code on my FreeSwitch configuration files, and it sucked in that XML like nothing, like butter. And it was making suggestions of changes to my FreeSwitch configuration based on the new requirements I wanted to change. That was amazing. It swims in XML. It was really, really good. I was quite impressed.
Yep. And I was pulling this up because I wanted to illustrate. I know that Anthropic has focused a lot on using XML tags and stuff, and I think the Claude models are particularly good. But this was one of my great surprises, is that I'm like, well, let me see what other models can handle this, and look at it. I mean, the numbers speak for themselves.
FreeSwitch configuration, just open up Claude XML, it'll suck in your FreeSwitch XML and help.
Yep.
So I found that amazing. And also, are you the person who did WebRTC stuff before?
I was the first
Berto?
person to implement WebRTC successfully in Safari, but that was a long time ago.
Okay. Thank
Jack,
Yeah.
are you double dipping on questions here, Jack? Is that what's going on here? Okay, let's give Chad one more round of applause.